Okay, so you should have looked at reflections 1, and then there's an optional extra example video if you need to watch that. This is reflections 2, which we're going to look at examples where the mirror line is not given and you might have to plot it using equations of straight lines. Now, just like the previous examples of reflections, the mirror lines will always be either horizontal, vertical, or at diagonals. You're not going to have to worry about intercepts and things like that and gradients. It's just really straightforward mirror lines that you're going to have. So in this case, for example, we've got a reflection in the shape in the line with equation y = 4. So the first thing you want to do is just plot that line. And a very common mistake is students will plot x = 4 rather than y = 4. So take a second to think about what y = 4 looks like, and then I'm going to show you. So hopefully you got it right. So if y = 4, which is here, well, y = 4 all the way along as well. So this is your mirror line. Once you've done that, it's the same as before. I'm not going to necessarily go into showing all of the working out this time around, because you can just go back and watch reflections 1 if you're not sure. But in this case, when you do your reflection, you end up with your shape looking like this. So you can see 2 units up, 2 units down, and so on. Just use the same method as from reflections 1 for this. Okay, second example. This time reflect the shape in the line with equation x = -1. Well, first of all, we need to find where x is equal to -1, which is here. And x is equal to -1 all the way down there and all the way up there. So we can see this is our mirror line. And then from that, we are going to do the reflection just as usual. So you can see 2 units to the left, 2 units to the right. And then we've got 4 units to the left, 4 units to the right. And then from that, we can construct our reflection. That line is 3 units high. And here is our reflected shape. Okay, next example. This time, the reflection line is y = -x. So we need to be careful about how this is plotted. Now, if it was y is equal to x, the equation would require for me to plot, for example, 1, 1, 2, 2, 3, 3, 4, 4, -1, -1, and so on. Now that is y = x. We want to plot y = -x. So whatever my y value is, I have the same x value but with a negative sign. So in this case, let's plot this line. If y is equal to 1, x will equal -1. Y is equal to 2, x is equal to -2. So you can see it's basically a reflection of y = x itself. And then our mirror line is just about to appear. That's our mirror line, y = -x. And then from that, we're going to make sure that we are going perpendicular to the mirror line and just doing the reflection as usual. So in this case, I can see I'm going 2 diagonals down, so I'm going to go 2 diagonals up. This is 1 diagonal down, 1 diagonal up. And then over here, I've got 2.5 diagonals. And then I'm going to go 2.5 up here as well. And then from that, we can construct our shape. So this one here is going to be 1, 2, 3, 4, 1, 2, 3, 4. That's going to be up there. Join them up and you've got your line. So remember to leave these construction lines and show the mirror line as well as part of your answer. Okay, question 4. Reflect the shape in the line with equation x equals 6. So first of all, we need to draw the shape the line x equals 6. So x equals 6 is here, and I know that x equals 6 x is always going to be equal to 6 along this point. Now you might remember from previous videos that this point here reflects onto itself. It's called an invariant point because it doesn't move, it stays where it is. The other points do change, so you can see 3 to the left becomes 3 to the right, and then from that we can fill in the blanks and we can see that is going to be our reflection. So invariant points are going to be interesting because we'll come across those later as well. We need to know where do they not move. Okay, question 5. Describe the single transformation from shape A to shape B. So this is our question in reverse. Now it's going to be a reflection. You probably guessed that because it's the title of the video that you're watching right now as well. But if you weren't sure in the exam, this kind of comes with a bit of practice and just by observing and a little bit of common sense here as well. As you can see that, okay, this is not a translation. The shape hasn't just simply been moved down, it's been reflected as well. It's not been made bigger or smaller, so it's not been enlarged and it's not been rotated. So what we want to do is figure out where is the reflection line. And it says there's a single transformation. So we find the vertices that are corresponding with each other. So I can see that vertices corresponds with that. I can see this vertices corresponds with that one here. And then we connect them up together. From that, we can work out the mirror line, because we know it's going to be halfway along those mirror lines somewhere. So this is quite convenient because each mirror line is 4 units high. So if I go 2 units along, 2 units along, and then I join those points, I end up being able to see that my mirror line is this blue line here, which is y is equal to 5. Now, in terms of how you should answer this, you need to say very clearly the key pieces of information. So number 1 is it's a reflection. Number 2, where is it reflected? What's the mirror line? The mirror line is y equals 5. So your answer is it's been reflected about the line y is equal to 5. And that's a full answer. You have to have both points. It's the reflection and the equation of the reflection line, mirror line. This one is a little bit harder. It's still going to be a reflection, and it says it's a single transformation. So we're going to also need to work out the mirror line. So we're going to use the same method as before. We're going to look for the corresponding vertices. So in this case, I am going to match this one with this vertices here, and I'm going to match this vertices with this one here. I could have chosen the other ones, lots of other ones, but I think these two should be okay. The next thing we want to do is connect them together. We're going from shape A to shape B. Now in the case of a reflection, it's not really going to make a difference which direction we're going if we've been given both shapes, because we just want to figure out the mirror line. So in this case we count. Now before we had 4 units, this time we've got diagonals, so we can see we're counting 1, 2, 3, 4 units as well. So in this case, the second diagonal is here. Now in the second line, you can see we're going to go 1, 2, 3, 4, 5, 6. So I now need to go 3 units. 1, 2, 3. And that is where I'm going to put a little cross or a dot, and I can see if I connect both of them together, I get, if my computer doesn't keep glitching on me, I get my mirror line, which is this line here. Now we need to know the equation of this line, but luckily the mirror lines are quite straightforward. In this case, y is equal to x. So you've got 1, 1, 2, 2, 3, 3. If you look at all the coordinates, y is equal to x. So the answer to this question is, this is a reflection, and about the line y is equal to x. Now, just like before, the next video on reflections is going to be some practice for those of you that need a bit more help. But at this point, we've covered all of reflections. So the next video is going to be optional practice. Otherwise, you'll move on to the next part of transformations on the playlist. Hit subscribe, smash the like button.